Hello again, everybody. What I want to talk about today is a relatively straightforward analysis, which is going to be about using the correlation function in SPSS. Now, correlations are interesting because while they are for a bivariate relationship, there are actually multiple types of correlations. Now, in the past, when we've talked about things like t-tests or ANOVAs, it's generally speaking been a very sort of straightforward process that we've got one test, and our data must meet that. Now, when we talk about correlations, we'll talk about them in a very similar way, in the sense that we interpret them in a very similar way. However, we're going to recognize the fact that later on, if we chose to, there are going to be correlations that are going to be appropriate for different types of data. So for today's discussion, we're going to be focusing on what we refer to as the Pearsons correlation. And the Pearsons correlation is a correlation that we can test when we have two variables which are both going to be normally distributed. So by their very nature, they must be continuous level data. Now, again, it's a bivariate analysis, and in some ways, it's one of the simpler ones for us to set up, because since we're making the assumption about the normality of the data, there's very little else we have to be necessarily concerned about. Now, obviously, we want to make sure we have an adequate number of cases. We want to make sure that our data is in the right format. But in terms of the actual hypothesis test, we are not so concerned about what that distribution looks like, except that it's going to be normal. Now, what is a correlation test doing for us? Well, it's going to be testing the hypothesis about the similarity between two variables. Now, don't be confused by the fact that actually we can select multiple variables, by which I mean more than two. The correlation itself, however, is only ever going to be an analysis of two variables. So let's take a look at how we go about that. Now, the data you can see in front of you is a data set that we have of state-level crime data. Now, you also will note that this includes some population demographic data as well. Now, I've even gone a step further, and I'm going to scroll all the way to the right here, and I'm going to show you. I've actually calculated out a couple of new variables, and each one of these is going to be a crime rate. And one of the things that we've talked about in the past is that when we start doing analysis like this, because of the different sizes of the states, and this works as well at any time that we talk about a geography or an aggregate, once we have aggregates of very different sizes, so for example here, California versus Rhode Island, enormous difference. We know that using or comparing count data is not going to be the most appropriate way for us to work on it. So what I've done instead, as you can see, I've created violent and property counts and then an index count. Now that's all of our Part 1 Uniform Crime Report data. And then I've also created over here on the right, highlighted in yellow, rates per 100,000 in the population. So let's start off by just asking ourselves the simple question of whether or not there's a relationship between the violent crime rate and the property crime rate. And looking here, it's not 100% clear that there is one. Again, we're just sort of eyeballing it. You can see that we definitely have a lower violent crime rate than we do property rate, which is, I think most of us argue, a good thing. So let's take a look. So we're going to go to Analyze. And then partway down, you're going to see that there's a function called Correlate. Now, you can see that there are a number of different options here. We're only going to worry right now about the bivariate correlations. Let's select that. Now, I said to you before that our discussion today is going to be focusing only on the Pearsons correlation, which is when we have two continuous variables. And you can see that SPSS actually defaults to the correlation coefficients being run for Pearsons correlation. Now, a Kendall's tau and a Spearman's are also options, and they're going to be used when our data is not measured at the continuous level. So we can actually still run correlations, and we interpret them in a very similar way, although with some caveats associated with it. But we run them in a very similar way as we would if we were running continuous data. But for the moment, we're just going to treat this data as continuous. Now, the question I asked a moment ago was about the relationship between the violent and the property crime rate. So I'm going to scroll all the way to the bottom, and you can see that when I bring violent rate over, my OK still stays grayed out. In other words, I'm not allowed to move forward. And that's because I've only selected a single variable. If I also highlight property rate and bring it over, then you can see right away the OK has become ungrayed. I can now click that. You can see as well the default here is it's going to flag significant correlations. All that means is anytime our significance value goes below the 0.05, it's going to put an asterisk in to tell us that that's a significant relationship. And the test of significance is going to be based on a two-tailed test. And again, that is just the default. If we wanted to, we could switch it over. With that in mind, let's say OK. Now, the output for correlation is a little bit underwhelming, but at the end of the day, it's going to tell us pretty much everything we need to know. So you can see here on the left-hand side, we have our list of variables, the violent rate and then the property rate. Across the top, we have the same variables listed out, violent rate and property rate. And so what the table is trying to do is look at the relationship of one to the other. Now, the reason it does it this way is because, as I said before, we can actually include more than two variables, although we can never look at more than a bivariate relationship at a time. I'll show you an example of that in just a moment, but bear with me here. So you can see that the relationship between violent rate and violent rate is a relationship of 1. In other words, it's a perfect relationship. It has to be a perfect relationship. It's comparing one value to itself. And you can see that if we go down here to the second row, second column, this is property rate, this is property rate, also a 1. Now, what becomes interesting or more meaningful for us is if we look at the relationship between property rate and violent rate. And again, it's repeated right here across the top as well, right? Violent rate to property rate. So it's telling us the same thing between these two cells. So we have three pieces of information here that are important for us to recognize. Now, it tells us the n, and that's important simply in the sense that we're going to know the degrees of freedom associated with the test. But it also tells us the significance value. And now right away it's telling you that with a sig value below 0.05, there is a statistically significant relationship between these two variables. Now, that's not new. We've done that with the t-test and the ANOVAs before. But here's what's interesting about a correlation. Correlations run between a value of exactly -1 and +1. And again, here you see examples of +1 when the values are compared to themselves. Now, that's what we refer to as a positive correlation. The idea is that with a positive correlation, as one value goes up, the other value goes up. Or if one value goes down, the other value goes down, that the relationship is the same between them. A negative correlation or negative relationship is going to suggest that as one goes up, the other goes down, or as one goes down, the other goes up. Now, what this positive value here tells us, and we know it's positive because it doesn't have a negative sign before us, that 0.491, which is our obtained test statistic for this, it's telling us that there is a positive relationship. In other words, as property crime goes up, violent crime is also going to go up at the state level. Now, what's interesting here is I just told you a minute ago that the correlations are bounded between -1 and +1. What that means is that we can actually interpret that 0.491 in a very general sense. And in your text or any text that you use, you're going to usually see some boundings that are going to be, in the language here might be a little bit different. It'll say something like 0 to 0.2 is going to be weak to no relationship. 0.2 to 0.4 is going to be a weak to moderate relationship. 0.4 to 0.6 is going to be a moderate relationship. 0.6 to 0.8 is going to be like a moderate to strong relationship. And then a 0.8 to 1 is going to be a strong or perfect relationship. Now, in this case, we have about 0.491, which falls almost exactly in the center there. So we would say that there is a positive, moderate relationship between these two variables. And when we get into our discussion of regression later on, this R is going to become even more meaningful. But for the moment, that's how we would go about interpreting this. Now, I just want to show you one last thing here. I'm going to go back to my regression command. My correlation command. So I'm going to correlate bivariate. And now I'm also going to throw in that index rate. Now, we know the index rate has to be associated with the violent rate and the property rate. If you remember from our discussion of the Uniform Crime Report, violent and property crimes added together are going to give us the index crime rate. So, going to give us the index count. So let's say OK. And now you can see why that 1 becomes a little bit more meaningful and why the data is sort of structured this way. You can see that in this case, we're actually looking at 3 sets of bivariate relationships. So the violent rate, which we've already seen before compared to the property rate, which is still the 0.491. Now we've got the violent rate correlated to the index rate, and then the index rate correlated to the property rate. So we can actually look at all three. And remember, the top here is just mimicking the bottom. So you only need to look at one side. So either above the ones or below the ones. Don't look at both because you're just going to double up on the same answers. Now, what that suggests to us is that the relationship between the violent rate and the index rate actually falls in that sort of moderate to strong relationship, while the index rate to the property rate is actually going to fall in that strong relationship. So all of these are positive, statistically significant relationships. And this is the benefit of using a correlation. Now, in this case, we would refer to having multiple ones like this as a correlation matrix. That's about all you need to know in regards to running correlations in SPSS. As always, if you have any questions, please feel free to let me know. Have a great day.